Hello guys, so this is the second part of the video series that I'm doing on the customer segmentation and customer churn analysis. So I think the first video that I posted consists of a lot of information about the data set itself. Like I was actually looking at the ISP, Internet Service Provider data set, and trying to understand what the data consists of, what all information you can gather from the data set. You can do an exploratory data analysis. You can look at each individual variable, how are they impacting in terms of the overall customer churn rate. So we did a lot of that analysis in the first video, so have a look at it. But this one I'm just going to be focusing on the clustering analysis. That means how do you create clusters once you have all the data that you have analyzed, and now you're in the process of segmenting out into different groups. Okay, so this would be something that you might be using it as an additional process on your customer segmentation analysis. Okay, so let's get into it. Okay guys, so this is the step I think we left at the end. We did ED analysis on each of the variables that were present in the data set. After the EDA, we're going to jump into clustering analysis. We can see, this is the data set that was created at the end. We had gender, senior citizen, partner, dependent, tenure, phone services. These are the multiple different types of variables that we were dealing with. But you also know that this is a label data because it has the churn at the end. So churn in the sense that we know who basically left the service. So we have that. It's basically a label data. So in order to make it unlabeled, what we can do is we can drop the churn column from this data set. Okay, and then that becomes a non-labeled data set, and we don't have any information about who left the company or who did not, and we can create a cluster to see what all different types of segments can come out of it. So we'll drop that column, and then we can figure out like how many columns do we have. We have after you drop it, you'll have the 27 of them because previously it was 28. So now what we can do is we can start working with this data set. So the first thing that you need to understand from clustering analysis is that you have to standardize all the columns. Okay, you have to create a standardized scalar column for all of these columns. The reason why we do that is because there could be different magnitudes across different groups, and that that can affect in terms of which variables might be more significant in creating clusters. So if you look at it from this data set standpoint, a lot of them are actually zeros and ones, so that's great, but some of them are in numerical nature or continuous variable. They have the magnitude of them can have an effect on how they can be affected in creating the clusters. Because what is happening with the clustering analysis, we are looking at the distance between the two data points using Euclidean, Manhattan, all different types of like a Cartesian coordinate type of data set techniques in order to figure out like how these data points are related to each other. So it's very important for the data to be scaled properly. Okay, so that's the reason why we do the standard scalar to make sure that we don't run into any problem later on. Okay, so we'll run this query, and then after that we'll go and create a data frame from the scale data. Okay, and then what we're going to do is now what we are doing is we are trying to determine the optimal number of clusters that we can use in our analysis. So one of the methods that we usually use is called the elbow method. Again, if you're carrying out let's say any kind of clustering technique, usually in this case we are doing a k-means clustering. So in k-means clustering, it will try to figure out again the distance between the data points, and it will create centroids, and depending on again how many centroids you create, it creates different clusters. So elbow method is going to figure out either the inertia or the cost function, okay, of each of the each time you're creating different number of centroids or different number of clusters. So it the more the centroids or the number of clusters are, the more the cost function will get get penalized. Okay, so we'll run that process. I think we'll this time we'll basically do 1 to 11. It's going to go through again the process of doing k-means clustering to figure out the cost function. Okay, so that is what this particular code does, and then after that we're going to print it out and see how it looks. So if you do print it out, you'll see that you have the inertia and you have the number of clusters. Okay, so the inertia is nothing but that cost function that I'm talking about. So initially the the inertia will be much higher, but as you create more number of clusters, that particular inertia value keeps going down. So as it goes down, you can see that the lower the number, the better it is, but you have to figure out what is the optimal number that you want to choose from. So in this case, probably 4 to 6 might be a range where the rate of change is much lower compared to what we saw from 1 to 4, right? So that's where it gives you an indication of what is the range range of like optimal number of clusters that you can choose from. The other thing that you can do is something called a silhouette score. Silhouette score is another technique where you can figure out what is the number of optimal clusters that you can create. So in order to do that, you have to run the code for silhouette score. Silhouette score, again, it has it again creates a graphical method, or it's a graphical process of figuring out if the silhouette score is closer to 1, the better the clusters are created. If the silhouette score comes closer to 0, then the clusters are not created properly. Okay, so the range of a silhouette score is from -1 to 1, but negative kind of like if it goes below 0 as well, it's not a good indication. So what we do in this particular code is that we figure out a silhouette score on each of the different number of clusters. Okay, so when you run this code, you will get something like this, and I can just show it to you how this computer does that. It's an optimization solution in terms of how it runs it. It runs one after the other, basically. It looks at one cluster, it looks at what is the silhouette score, it looks at the second number of, it creates 3 number clusters, and it looks at the silhouette score. Cluster 4, it looks at the silhouette score, and so on and so forth. Like we have given it from 2 to 10, so it basically calculates the silhouette score from 2 to 10. It doesn't take too long, but you can see that this is the graph that it gives you, and the y-axis is basically a silhouette score. So from 0.16 to, again, it goes up to a little bit higher to 0.17, and then it goes down dramatically. So remember, the higher the silhouette score, the better it is. So at a cluster of 3 and 4, that's where the highest silhouette score is coming up, and that's what the elbow chart is also telling us, that would be the most optimal number of clusters that you might be selecting. So these are the 2 possible like graphs that you can use in order to figure out what is the optimal number of clusters in your data set. Okay. So the other thing that we can do is within the silhouette score, we can actually look at silhouette scores for each of the clusters within those cluster groups. Okay, so in order to do that, you have something called a yellow brick as one of the packages that you have to install. Okay, you might not have that, so you'll have to do pip install yellow brick. Once you install it, you will use something called a silhouette visualizer. Okay, silhouette visualizer is another type of technique that you can actually use in order to figure out like how it looks graphically. So when you run this, you will see something like a silhouette plot for k-means clustering. Okay, for the 7,000 samples that we have for 7 clusters. So we actually gave a value of 7 over here, and it plotted down from 0 to 6 all of the different silhouette scores for each of these clusters. Okay, so the average is what we saw in the graph above, but you can see that some of these cluster number 3 and number 4 has a lower value compared to the other clusters in terms of the silhouette score. So that shows that number 3 and number 4 might not be the right clusters that you should be in your data set. So that basically shows that we have created too many of the clusters. So but if you see that on, if you do it for 4, that's the optimal one that we saw, you can see that there's a clear indication of how these silhouette scores are different for each of the clusters. Okay, so that way you can say that, okay, yeah, maybe number 4 is the right set of clusters that you should have in your data set. Okay, because it has a very distinct differences, and then also the silhouette score for each of the individual clusters labels are pretty high. Okay, so that's how you're going to be figuring out the optimal number of clusters using a k-means clustering technique in your data set. Okay, I think that's about it. I will cover other topics in this series. Okay, and I'll talk to you in the next video.